So welcome everyone. Thanks for coming to my talk. And you get the privilege of also seeing my presenter notes because I wasn't able to get this place working. So I'm hoping that you're having a good time today at the Hadoop Summit, the first day of the kickoff. And this talk is 10 easy steps to make your cluster hum. A little bit about myself. My name is Alejandro Fernandez, and I'm a software engineer at Airbnb. This is already my 4th Hadoop Summit talk, and before I was at Hortonworks for a couple of years working on Apache Ambari as a PMC. So I know exactly what cluster management is like, some of the pain sometimes you feel, and I'm hoping to alleviate that pain and hopefully make it easier for everyone. I've also contributed to Hive, Superset, and Airflow recently. So first, let's start off with a quick poll. How many of you here manage a Hadoop cluster? Okay, awesome. So I have the right audience. And now let's see. How difficult is it for you? Is it pretty easy right now? Medium difficulty? Okay, is it difficult, right? Okay, so we got a pretty even distribution. So that means that there's room for improvement. Good. So this talk is geared for people that are in DevOps, all of your infra teams. And in the past, when we talked about DevOps, there was a very strong correlation between developers that are writing new features and also the teams that are supporting them. So doing the operations, the deployments, looking at alerts. And nowadays, it's actually 3 branches also combined with QE. So it's taken on more roles. And historically, DevOps is something where engineers that were really good at database administration were really good at and evolved into this field, but now it's a combination of all these things. So people that have scripting abilities, but also know how to operate a large scale. They know about S3, but also a good testing background. So we want to combine all these things and make sure that we have the continuity of our business while adding new features and maintaining everything running. So the talk is, again, 10 steps to a smoother cluster. So I'm going to talk about first how to automate the addition of new hosts, whether you're using something like Cloudera Manager or Ambari, how to do host name discovery so that you're not stuck hard coding host names. Also artifact management, just some good practices around how to store your artifacts, how to actually deploy them, version them, hash them, sign them, etc. Also deployments and upgrades. This is extremely crucial because this is essentially your bread and butter. Every single time that you make a deployment, you take some risk that something is going to fail. So how do you guard against that? And what tools are at your disposal to make that easier for you? The 5th step is how to make troubleshooting easier. When things do go wrong, how can you look at the logs easily? And you don't want to be SSHing and SCPing logs, but instead you want to quickly be able to analyze your patterns, your trends, and know exactly what's wrong and where, so how to pinpoint that. Step number 6, we're going to talk about Hadoop metrics. And in particular, I'm going to focus on tools like the Ambari metric system. Step number 7 is really be data informed. So drive your decisions about deployments based on the data you've collected. It shouldn't take a developer time looking at, or even a DevOps engineer, time to look at dozens of dashboards to figure out where your deployment is in a safe state, or you can go to the next batch. Instead, you should automate all these things and have processes set up to figure out whether you're collecting the right metrics and if your health is in a good shape. Step number 8 is basically automate as much as you can with any tools out there, whether it's like Uzi or Airflow. And the goal is use ETL to do things that are automated but make sense in a Hadoop world. So everything from taking your backups, your database exports, your snapshots, even Hive compaction. So automate all these things with the tool so that you get reliable SLAs and you can meet your schedules. Step number 9, it's really important to be able to visualize your trends. We're not just DevOps, we're actually also planners. We want to have foresight into the future to make sure that our clusters can scale for the next year, 2 years, 3 years. And so we want to find these patterns, these trends, but also nowadays it's even more common to have things like team quotas, or also look at audit logs, or like engage some of your users and actually share your dashboards. So I'm going to talk about how to use Apache Superset as a way to look at dashboards and look at trends. And last but not least, automated maintenance. If you're using a cluster management tool, such as Cloudera Manager or Ambari, these already have features, but sometimes there's a lot of really custom things. So I'm going to talk about how to clean hosts and keep your cluster healthy. And last but not least, we'll do some Q&A. And feel free to interrupt me if you have any questions. This is meant to be also a forum, and so I encourage that as well. So at Airbnb, we use Chef, and not everything that I'm going to talk about here in this talk is about Airbnb, but it's sort of my learnings also coming from Hortonworks. And there's a ton of different ways to deploy instances to your clusters, and just Chef is one of them. You can also do scripting with Ansible and Puppet. But the reason why we like Chef is that it's really easy to manage, and it's built using Ruby. And so we've got a lot of people that are familiar with Ruby already, so it made sense for us. And the reason why we like Chef as well is that you can sort of encapsulate what's called a cookbook. And so a cookbook is a collection of template files and attributes and recipes, and you use all these things to deploy new hosts to your cluster. So attributes can be things like properties. You can also get passwords and store them in a data bag that's securely encrypted. And the goal is to take the guesswork out of configs, because you want it to be either environment specific or in some sort of case deployment specific. Recipes essentially combine these patterns and blocks to do operations. So everything from installing packages, creating directories, creating users and groups, creating symlinks, all these things that you would automate using scripts, you can do with Chef as well. And a role is a traditional role when we think about like a name node, a data node, a host manager, in one of these environments. And the last reason why we like Chef is that it's very repeatable. It's idempotent, and so if for whatever reason one of your hosts gets into a broken state, you can just converge it again, and it'll fix whatever was missing. So you've got your new host up. You've deployed it using Chef. What's the next step? You want to add it to your cluster. So who here goes to one of these two tools and just adds a new host? Okay, a lot of hands went up, right? So are you doing that through the UI or using an API? UIs, APIs, automated. Okay, so if you're a DevOps engineer, your time is precious. You're looking at 1,000 things per day. And so as soon as you detect that one of your hosts is up, you can actually figure out the Chef role, whether it's an Airflow worker, a scheduler, new data node, and audit automatically to your cluster management system. So you want to automate as much as you can. And with both of these tools, you have that ability. With Ambari, you can make a curl call to one of the REST endpoints. With Cloudera Manager, you can use a Python API. And as you add your host, you can set it up to do things like rack awareness. If you're also deploying with Ambari blueprints, there's another feature called host discovery. That means when hosts come online, they'll automatically get assigned their role, and they'll even start for you, right? So you want to automate all these things. Here's a quick reference. You're not expected to read this stuff, but just know that it's pretty simple to do this both in Apache Ambari and Cloudera Manager. Cool, so moving on. Configs are extremely painful to manage sometimes because there are so many, first of all, really complicated, and you have to worry about them when you're doing upgrades. So have any of you ever had a problem where you're merging configs during the middle of an upgrade? Or like you're looking at it. So in the olden days, right, you would do a manual upgrade and you had to do these things by yourself. Nowadays, when you're moving from one stack version to the other, these tools will do a lot of the guesswork for you. However, there are some cases in which when you use one of these configs, they contain, for example, a list of hosts. And so if you're hard coding host names, that's a very bad thing. And so instead, what you want to do is figure out how to make host replacement easier. And there's 3 ways to do that. The first method is to use something like Stack Advisor and Apache Ambari. The reason why it works great out of the box is that in your config, so like your yarn side XML file, for example, you can use the double brace notation and have a config like zookeeper hosts. And in your Python, your params.py file, you can come up with that list. So it's pretty easy to do. However, if you're running custom services, you have to essentially like write this small code snippet. If you're using Chef, you run into similar problems. It's not as easy. You can basically have an attribute file that says, here's my list of hosts in my staging cluster. Here's my production cluster number 1 and production cluster number 2. The problem is if you do a host replacement, you now have to go like push something, know what the new host name is, and that may even require a service restart. So welcome to the third and ideal solution, which is to use something like SmartStack, which is open source at Airbnb. So SmartStack is essentially an HA proxy that does local load balancing. So let me repeat that. It's local load balancing. You're not using an external load balancer. The host itself figures out whether it should be the one to receive the requests. And the reason why this is really cool is that you can have a name, for example, metastore.synapse.airbnb.com, and that's your name for all of your Hive metastores. So if you ever add a new host using that role of metastore, it gets automatically added to this list, and you don't have to worry about config changes. So this is just a reference on that same thing I just talked about, how to do it in each one of these 3 systems. You can go back to this if you want to refer to it later. Cool. So you've got things deployed, configs are working fine. Well, guess what? Now it's time to deploy some custom artifact. Developer on your team or someone says, hey, we need to install this new thing. I need to make some changes. So how do you easily and safely do that? The first thing that I want to stress upon is that we need to be able to trust our artifacts. So where they came from, are they signed? Are they properly deployed? And when we think about an artifact, it really could be anything. It's not just the package that you built, but also it's the build log, it's the test result, because these things are a cohesive unit. When you make a build, that build came from an environment. So if you did a build on a local machine on a developer's laptop, like that's really hard to reproduce. Again, what if they changed or upgrade their Java version, right? So instead, what we try to do is make your build system repeatable. So we use things like Docker or VMs, and we version these things. And we know exactly which compiler you used or which version of, say, Python it used. We also want it to be trackable. When we deploy an artifact, whatever it was, we want to know where it came from, what the upstream is. And so for us in our case at Airbnb, it's like a get SHA number, right? And we also want it to be trustworthy. This is especially common in Apache. When you're releasing artifacts, you always sign them, and you put the hash artifact, right? So whether it's like an MD5 or something else, and you also sign it. When it comes to signing, you have a couple of options. You can reach out to a popular certificate of authority and get your own. That costs money. Or you can build your own local infrastructure for doing certificates and signing. But the point is, whether you try to do something really enterprise ready, such as using Artifactory or Nexus, or even something simple, such as just checking in your artifacts on S3 and saving it to, checking it to Git and saving it to S3, you want a story on artifacts, right? It's going to make your code repeatable. And also, if you ever want to downgrade, you can always refer back to what build you're running. Okay, so now it's time to deploy. If you're using Cloudera Manager or Ambari, you're probably going to need a repo server, and I'm sure most of you have one already. But you can also think of that as a single point of failure, right? It does take time to set up, and if you're provisioning new hosts, those hosts are grabbing their artifacts from that server. So also think about making that be load balanced or highly available. There's a ton of different ways as well to take backups, and which is essentially one of the prereqs of any deployment. Whether you do it manually, so your HCFS image dump, your Hive Metastore backup, your HBase snapshot. You can do all these things manually, figure out what your environment is, or you can even use open source tools like the Data Lifecycle Management system. And then the actual step of deployment is what should be the easiest part, because you're just deploying the parcels. The orchestration itself is what I think is difficult. The orchestration, whether you're doing something like a rolling upgrade or express upgrade, this is where things can go wrong. And so you want to be ready with what your downgrade scenario looks like. Both of these tools, Cloudera Manager and Ambari, have ways to do this in an orchestrated rolling fashion. And there's a lot of different ways to benefit from these tools by calling the APIs ahead of time. So for example, with Ambari, when you're doing a rolling or express upgrade, after you've installed the bits, you can actually run pre-checks. So from the current stack version that you're on to the new stack version. And these checks are really specific to the version that you're going to sometimes. But for the most part, these are like a recipe of things that you should always be constantly running. So for example, are all of the services up? So if you plan to deploy this week or next week, you can run these pre-checks in advance, and I'm going to explain how to do that as well using the APIs. Are all the hosts out of maintenance mode? Because hosts in maintenance mode would not participate in the upgrade. Are all hosts heart beating? Things like that. And there's literally a list of about 30 or so different steps. If you're doing an actual rolling upgrade, the tools will take care of the orchestration for you. But sometimes you're just deploying a jar. Let's say you're adding something to the class path, or you're doing something with like a brand new Hive Metastore listen or a Hive hook, right? So these things you typically deploy in a rolling fashion. And so there's a benefit in using these tools to do so in batches. So when you use the tools, you can set up what your failure tolerance levels are at, what your sleep intervals are at, and if you ever run into any problems, you can always downgrade that option. So just for reference, if you're using Apache Ambari, here are some of the APIs to run the pre-checks, to start your upgrades automatically, and to check the status. The status actually returns a JSON structure with a lot of content. So each single step where it's in. So for example, like Zookeeper or HCFS, which particular group and which instance and what operation it's doing. Okay, so you've got upgrades going. What happens if something goes wrong? So this is where you want to have a tool like Elk or log searching. So who's got something like log searching in their cluster? Awesome. So what other tools are you all using? Feel free to shout it out. I'm just curious. Any other log searching tools? Splunk? Okay, good. Okay, cool. So the whole theme is have an easy way to troubleshoot, right? When the situation arises, you don't want to be scrambling to figure out where your logs are at, especially if you have a bug in 1 out of 10,000, data nodes. Hopefully you have a cluster that big. And so to talk about more using these tools, so Kibana and Elasticsearch are both open source. So Kibana is the topmost layer that does the UI for visualizing and searching log files. Elasticsearch is basically an index, and it's backed by Lucene. And so it allows you to do, I believe, full text search as well. And then Logstash is your ingester. So think of Logstash as the converter between the log files, its format, and putting that into something that Elasticsearch can actually go ahead and index. At Airbnb, we actually have a massive Elk stack, not just for Hadoop, but for the rest of our infra. And so this is something that's going to be really, really valuable when it's time to troubleshoot. There's also a couple of other tools for searching out of the box. So LogSearch actually ships with Ambari. And what's cool about this is that the UI is really easy to use, and it was meant for scale. So you can filter for a log level, such as fatal, error, warning, etc. You also can select the time range. There's a histogram as well to get the count, for example, and you can even drill down to the actual log message, which host it came from, and explore all these things. Another neat feature about using log search is that you can also select which services you care about. So let's say I want to look at Ranger, KMS, or just a user sync. As well as visualize these things. And you can even do searches on your text, so whether it contains a particular expression. And what's useful about this is that it's not just for errors, but think of it as a way to also look at audit logs, for example, whether it's HCFS audit logs, Ranger audit logs, or even Hive, right? We live in a world nowadays, especially with GDPR, where we have to care a lot about security. And so we need to keep this in mind. So utilize as many tools as possible that make sense with their existing infra and that are easy to use, basically, right? We don't want to have tool overload, but we also want to be able to get stuff off the shelf whenever it makes sense. Okay, so the next really interesting topic is how to collect metrics. And there's a ton of tools out there already, but at its core, I'm just going to give you some examples. Again, this is not stuff that we particularly are promoting at Airbnb or even we use these things, but again, just a general idea of how you want to think about collecting metrics. So because Hadoop by itself is so large, it's nearly impossible for anyone to get a grasp of what the state of the cluster is. And it's not a Boolean, is the cluster healthy or unhealthy? It's essentially this gray area. And so collecting metrics is a great way to come up with concrete numbers about where we are and where we want to go. If you start at the base, I'm just going to come up with an example for Zookeeper. But Zookeeper, so it in its quorum service is used by a lot of other different services, right? So obviously name node, also leader election and all these things. And it's now actually common as well to have multiple Zookeeper servers in your cluster just because you want to get sometimes isolation. And this means that you need to also track individual metrics per Zookeeper cluster. So what is your timeout like, your latency, your number of RPC calls? When you also look at the HCFS and yarn layer, there's a ton of metrics. So the most popular way to just get some information on HCFS is to just go to the web UI, right? So you get info on all your DataNodes, but what if you want more information? So garbage collection, for example, extremely important as you scale up the number of hosts, right? Every single time you have to do a GC pause, you're essentially not processing things as quickly as you can. And so what may work now may not work 2 or 3 months down the road when you hit another bottleneck. And so with HCFS, we can use WebHCFS as well to collect stats, and also JMX. So JMX is by far probably one of the most important ways to collect metrics on HCFS and Yarn. You've also got the Yarn or the Research Manager UI that has counters for your jobs. So how much memory is it using? How many mappers and reducers? And so this is your way of finding out if one of your users, one of your data scientists is doing something wrong, right? If they're launching a job that's essentially taking away too many resources, or do you have like a runaway job, basically? This is how you track this stuff. You get metrics, right? You can also use some tools off the shelf. And so I'm going to also talk about Ambari metric system, which is just one of these tools. AMS is essentially a metric gathering system for Hadoop. Now, it doesn't actually try to just do metric gathering. It actually allows its services to sync information to it. What this means is that it has really tight integration with the Hadoop stack. It has Hadoop syncs, basically. So HCFS, HBase, Kafka, etc., all of these send meaningful and important metrics to AMS. So what's cool about AMS is that first, it's highly scalable. It scales actually horizontally, and it's backed by HBase. because when you're storing metrics, you think of a metric as timestamp data, right? You don't think of it as like, I'm coming up with another example. I don't know, like the key isn't like an origin. Sometimes it's usually time, right? And then it's also built using Phoenix, which is the querying layer, so that if you ever wanted to query the metrics on AMS by yourself, you could do that with Phoenix and the SQL utility. It's also got HA. You can set up T collectors. And what's also cool is that it integrates with Grafana UI. So I mentioned before Kibana. So Grafana is yet another tool for visualizing metrics. There's another one. Yeah, there's a whole bunch of other ones. Oh, one last thing is it also has support for anomaly detection, which to me is the holy grail of metrics. Just because by themselves metrics are meaningless unless you can put some intelligence behind it. When you look at, for example, trying to correlate GC policies with an increasing number of data nodes and like a high latency, like all these things make sense. So if you combine all these metrics together, you can actually come up with a larger story, not just an individual metric. And I think a lot of the time when we use some of these tools, we just get one chart, and it's up to us to decipher what the rest of it means. So we want to use tools that give us a larger, better picture. Okay, so our metrics look good. I think it's safe to deploy. I wish my setup was like this. It's not as advanced, but actually I would want a simpler setup, right? I don't want to be looking at 1,000 metrics just to figure out whether it's safe to deploy. So on a similar theme of metrics, let's talk about telemetry. So telemetry is, to me, the notion of using the metrics you've collected to make a meaningful decision about whether or not it's safe to deploy something. I'm just going to talk about one example of using StatsD, which is essentially, think of it as an interface. DataDog implements StatsD, but you're emitting metrics. And I want you to think about embedding this in any of the tools that you deploy. So if you're writing custom code, can you come up with a metric that you can emit somehow? So whether it's a counter or something you can increment or decrement. So when you're doing deployments especially, let's say that you've got some code running on the old version and you just rolled out to 10% of DataNodes, something else, right? Part of your metric can be, for this new job that I'm testing that provides some added functionality, on the newer version, here's how many successes I've seen. Or actually one feature that I worked on was adding security to our Hive Metastore. And so we wanted to prevent users from changing locations to things that we felt could have been an attack. And so at first, when you roll out these features, you do so in a stealth mode. The feature's rolled out, I have a flag that controls whether or not it's going to actually prevent an action. But before I actually do that action, I want to emit a metric whether or not it would have prevented that action, right? So this is a very easy way to leverage tools such as DataDog or any metric gathering service. So the point of this slide is that it's pretty easy. Here's a really simple, just gauge a metric. So with telemetry, a lot of these tools have built-in functions for taking averages, minimum, maximums, and setting up alerts. Just another simple metric. And it can look like whether it's passing, you're in the middle of a deployment, or flaky, and you want to isolate these differences, right? Okay, so we use Apache Airflow a lot at Airbnb, not just for our data scientists, but also for our work. I'm in the data infra team. So we use it for things like Hive compaction. We take database exports of a lot of the things like our Hive Metastore, for example, or our Ranger database, and we use these things to later do analysis and aggregation. So at its core, Airflow is just an ETL tool. It's not streaming, but it's extremely easy to use because you can write your DAGs, your pipelines in Python. And for us, that's a huge win because we understand this language already. We know how it works. It's highly scalable. At least the way that we've deployed it, we've got a scheduler that handles 15,000 tasks at peak that are launched. And it's a Celery, queue, and a Redis broker. And we've got a lot of different workers with web servers running. Here's a quick example of what the UI looks like. But it's got features such as RBAC. You can look at the upstream and downstream dependencies. You can retry automatically. It's got a ton of really cool features. Plus operators. So think of operators as a unit of work, whether it's a Hive operator, Presto, or something, or in this case, Bash, which is really simple, right? And you can set up the dependencies. Like, I want to take wait for a partition to land, for example. Then I'm going to do some data analysis on it, save the results to a different table, and then send an email on the results, right? You can combine all these things and automate your work. And I forgot to mention that Airflow was open sourced at Airbnb by Max Bochman. He also was the author of Superset, which is a tool for visualizing data. And when we think about a DevOps role, you don't really picture yourself using a tool such as Superset initially, but it actually makes a lot of sense. Because we've exported our data, so Hive Minister or Ranger logs, etc. We can actually do analytics on it. So figure out what our trends are we meeting our SLAs, and all these things. And so Superset is extremely good at doing ad hoc queries. It's got caching, and your connections can be a ton of different things. Everything from MySQL to SQL Alchemy, Hive, Presto, HBase, etc. Here's just one example of some of the dashboards using Superset. But you query something, you visualize it, you figure out exactly how you want to portray it. There's a ton of different charting utilities and graphs and different ways to look at your data. And you figure out, okay, what's meaningful to you. And as an infra engineer, we essentially have a very important goal of business continuity, security, and reducing costs, right? And so we can actually inform the leaders, what we're actually spending, what we're actually producing. For them, it's really easily consumable in the form of dashboards. And last but not least, we want to automate maintenance as much as possible. Tools like Ambari and Cloudera Manager will warn you about unhealthy hosts. Does it have too many failed disks? Is the host not heart beating, right? But you actually want to take some action when these things happen. So we've actually built tools to automate these things for us. You can also, if you're on the cloud, then it's probably easier for you already. But you have to worry about potentially taking downtime depending on the type of service. For us, we wanted to automate it as much as possible. And so whenever there's a data node that goes bad, we just swap it up. Sometimes it's also important to do periodic restarts, not because the application itself is unreliable, but because it actually gives you a chance to make sure that the environment is in a healthy state should you ever have to restart it again. Cool. So thank you for your time. And we've got a couple minutes for some Q&As. I see some familiar faces. Yep, go ahead.
So at Airbnb, do you guys do the orchestrated Ambari upgrades when you do version stack upgrades, or do you do manual upgrades and orchestrate that yourself? What kind of techniques do you use?
So we actually use Cloudera Manager, and I can't talk too much about what we're moving to or what we're doing for upgrades, but I focused a lot on doing rolling and express upgrades for 3 years at Hortonworks, so I can appreciate the amount of work it takes. Yeah, I mean, is there a follow-up or? Yeah.
I may have a follow-up for that because I run parts of Ambari. I don't use the management infrastructure of Ambari, but I use AMS and Ambari views independent of the management side. Do you guys, I know you as an Ambari developer, have you looked at that at all? Or?
So actually, that's a really good way of either getting started or just picking up the pieces that you need without too much complexity. Ambari views by themselves can run independently, so can Ambari metric system, although I believe nowadays it needs Ambari infra tools to be also deployed. But yeah, good call. If you just need that tool, then just deploy that tool. Yep. What sort of blocks do we index? So I don't know off the top of my head. I know that the rest of the company does use it very, very heavily for the rest of Airbnb, which is huge. So obviously logs, yeah.
So you kind of talked about the cluster view of the world and all the cluster metrics that you're charting. How do you track how your applications are doing on the cluster? And if these applications go down, how do you go about debugging those?
So we've got a ton of dashboards for compute. Already Cloudera Manager has a really good view for what the cluster looks like in terms of yarn queues, but we got more than that because you actually want to track it to the originating source, which could be, in our case, could be an Airflow DAG, could be a user running a Spark job. And so we have a lot of dashboards built in to like let us know, top X or where it's actually coming from. Yeah. Mm-hmm. Yes. It is Python based, yeah. It's built using Flask and yeah. Cool. Again, yep.
Do you have any systems with multi-level deployments? Like you might need to reboot your entire cluster, which might take weeks. At the same time, you might want to upgrade various bits of your system which are much faster.
Mm-hmm.
So you want the reboot to sort of happen in the background, not getting into the way of faster deployments. Do you have that need? If so, how do you do it?
Not right now.
You don't have the need, or you don't have
We don't have the need right now. Yeah. Cool. So again, thank you for your time. Enjoy the rest of the conference, and refreshments are in the hall. All right, thank you.